Hello, Weizang team welcomes you to this video about spectral analysis and order tracking analysis. Vibrations measured on rotating machines show a frequency spectrum in which maxima occur at frequencies that correspond to a multiple of the machine's rotational speed. The multiples of the rotational speed are also called orders. This video discusses the options for performing spectral and order analysis with FlexPro. I use already imported data from RunUp folder. I select the acceleration signal and create a time frequency spectrum analysis object under Insert, Analysis, Spectral Analysis. I select spectrum type RMS amplitude, segment length 8192, overlap 95%, spectrum result, frequency is X and speed is Z, and I press OK. I present this in a suitable way in a contour plot named STFT. I double-click on the X-axis and under Scaling tab I select 1200 as end value. The orders, or so-called multiples, of the motor speed are already clearly visible here. In speed-frequency spectra displayed in contour plots, order cursor can be used. I activate the cursors by pressing on-off button under 3D Diagram Tools, Design, Cursors, and select Order Tracking Cursor under Toggle Cursor. The order tracking cursor appears in the speed-frequency spectrum as a diagonal line and marks locations of the same order. Order markers can be set to mark the order progressions under Cursor Tools, Cursors, Marker, Place, Order or Frequency. Now the orders can be visually marked with order markers. I will set 3 order markers at 2, 4 and 17 Hz. Using my left click, I select the order and press enter. I also set a vertical line marker representing a natural frequency or resonance frequency of the system. I double click on this marker and edit it. I want to cut out the marked orders and plot the resulting order curves in a 2D line diagram. To do this, we first calculate a so-called order spectrum in FlexPro using the Revolution Synchronous Order Analysis object. I select acceleration and speed and create an order spectrum object under Insert, Analysis, Spectral Analysis, Order Spectrum. I select Output Order Spectrum, Spectrum Type RMS Amplitude, Overlap 95%, Order Spectrum Result, Y Amplitude, X Order, Z Speed, and I press OK. I present this into a contour plot named Order Spectrum. I double click on the X-axis and under Scaling tab I select Axis Type, Linear Physical Division, Axis Type Division 1, Scaling End Value 25. The order spectrum can be thought of as a transformation of the speed-frequency spectrum where the frequency component has been transformed to the appropriate order of the speed. The orders are now simply vertical lines in the order spectrum. Resonance frequencies, which were visible as vertical lines in the rotational speed frequency spectrum, become hyperbolas in the order spectrum. With the help of the previously created analysis object, the order progressions can also be output as so-called order cuts by cutting out vertical lines in the order spectrum. These order cuts can be output as list or signal series. I copy-paste the order spectrum object and rename it as order cuts. I also create a formula object named orders and use the fpscript bundle operator. I double-click on the order cuts object and select Output, Extract Orders from Order Spectrum as List. Order cuts result Y, amplitude, X, speed. Evaluate at speed from 1000 to 6000 with increment 25. Procedure: extract orders energetically in the order band RMS. Orders from dataset. Orders. I present this into a 2D line diagram named order cuts with curve connection line type step line. The calculated order cuts now represent the RMS curve of a signal bandpass filtered around the corresponding order. Such a bandpass filtering of individual orders in the time domain can be realized with a further analysis object, namely the order filter. From the signal transformed into the revolution domain, individual orders can be filtered by ordinary IIR bandpass filtering, for example with the Butterworth bandpass filter, and transformed back into the time domain. Order filtering can be performed using the order filter analysis object. I select the acceleration and speed, and under Insert, Analysis Filter, Order Filter, I will choose Output, Filtered Orders as List. Orders from Dataset, Orders. Result Y, amplitude, X, time. I present the order filter in a 2D line diagram. Let's see now both the order filter diagram and the order cuts diagram. The data tab of the order filter analysis object again contains, analogous to the revolution synchronous order analysis object, all settings for the transformation of the time signal into the rotation domain. Let's compare order filters and order cuts. The order filter analysis object allows the calculation of sums of individual orders, both the continuous sum as well as the RMS sum. To do this, select Output, Sum of filtered orders. The same cannot be done with revolution synchronous order analysis object. In the order filter analysis object, the moving or block RMS curve of the orders can also be calculated and output over the speed. I can select Output RMS curves of filtered orders as list. Result Y, amplitude, X, speed. Evaluate at speed from 1000 to 6000 with increment 25. Although now a completely different algorithm was used, the result then agrees with the calculated order cuts of the order spectrum. We hope you enjoyed the video. If you have comments or questions, please do not hesitate to contact us.